Okay, concentrated HCl is 11.7 molar. What is the concentration of a solution made by diluting? So if I was taking the test and I saw the word diluting, I would look at my star chart on my blue colored periodic table. That formula that we need, M1V1 M equals M2V2, that is in there. You don't have to memorize it, okay? So I know when I'm reading this that I really want to pull out my variables. I want to write these down the side to make my life easier. So the biggest difficulty is organizing and figuring out which one is which. Well, if this says concentrated HCl is 11.7, I know the concentrated form is going to be my first one. Okay? It even tells me that. And it tells me I'm watering 25 milliliters down to 1,000. Well, if I'm making something that's more dilute, the more dilute one is going to be the larger amount, right? So that means my V2 would have to be 1,000 milliliters, and my V1 would be the smaller volume, 25 milliliters. And it says, what is the concentration made? So I'm looking for the concentration that I'm going to make. That part right there, pulling these out and identifying them, is your biggest challenge, getting them right, okay? Because there's always a tendency, well, I'll put the first two as M1 and V1, and the second two as M. It doesn't work that way always. So you got to be careful of that. After that, we're really just doing algebra, right? It's M1 V1 equals M2 V2. I'm looking for M2, so I have to get rid of the V2, so I divide both sides by V2. That way they cancel out. And I just have to plug my numbers in now. So my M1 is 11.7. My V1 is 25. And then my V2 was 1,000. All that put together tells me my concentration of my second solution. So M2 equals somebody. Okay. 0.29. It gave us three significant figures. Let's use three, so let's add one more number. But doesn't that round up? Is it 2.5? So there would be a 3. If we were working on significant figures, which is something we should always do. But questions on that? The math part is, I think, for most of you will be okay. I know you don't. Most of you don't like math. It's not your favorite subject. Let's put it that way. The hardest part is taking this and putting it over here. Okay, one more. Number 2. What volume of 15.6 molar ammonium hydroxide is needed to make 500 milliliters of a 3 molar solution? So I know I'm making a solution. I'm identifying or understanding that I have my 4 variables that I need to recognize: M1, V1, M2, V2. So I want to pull those out. So I see both of these molarities, right? Well, the M1 has to be the larger one, the more concentrated one. So that's going to be my 15.6. So that my 3 molar has to be the less concentrated one. And it tells me I'm making 500 milliliters of a 3 molar solution. So doesn't my 500 milliliters have to go with my 3? And it wants to know what volume of this one am I supposed to use. So like I said, I think that's the most difficult part. That's probably 60% of your obstacle, getting that pulled out. And then, again, M1, V1 goes M2, V2. This time I'm looking for V1. So I divide both sides by M1. And I just have to plug my numbers in now. So V1 equals 15.6 times, I just messed up, didn't I? 3.0 times my 500 divided by 15.6. It's very important that you put units in here. So my V2 then, V1, sorry, it's Thursday, blah, 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 all that stuff, all those excuses. Anybody have an answer for me yet? Okay. 96.13. Okay, we'll just run that off to 96.2. What are my units? Well, the M's cancel, so it has to be milliliters. It's very important to put your units down because sometimes this is going to be milliliters, sometimes it's going to be liters. Let your math tell you what your units are going to be. So, for the remainder of the time, you have plenty of time. You're going to work those 4, and you're going to finish whatever you didn't do yesterday on the other side.